questions that you may have still, we can go over that. Solving problems, I mean. Okay, if you have any questions, please write it in here in the chat and we will solve them. And I'm opening the my lab right now. Okay, I'm going to share my screen in a little bit. There are some questions. Let's see. I started preparing the quiz 1 for Friday. And I'm going to open up homework 4 directly because we should go through some questions in here. Okay, let's see. Okay, I'm going to go over this one by one, all right? So, yeah, Mustafa Mohammed, go ahead and ask. Yes, Mustafa, I cannot hear you.
Sorry, doctor, but I can't use the chat.
No problem, Mustafa.
Yeah, it's okay, right?
It's okay. Just students who can say hi, just say hi. It's just out of courtesy, okay? It's
okay. Thank you.
Okay, thank you. All right, so yeah, I'm going to share. If you write any questions on the chat, let me know, okay? Because I'm going to be on the other screen. I may not see the chat. All right, so I'm going to open up this. Okay, so let's go through this homework 4 all together, okay? In homework 4, there are 3 sections, 3.1, 3.2, 3.3, but we will just work on 3.1, 3.2. And so in this first question, it is talking about the slope of the tangent line to the curve f of x 2 over square root of x at the points where x equal to 1 over 9. Okay, if we have time, I'm going to get to it because we already recorded. From yesterday, we have some recordings, and I want you to watch the recordings from yesterday. Your section 1, I made up. We had a makeup class yesterday, so we had solved a similar question yesterday. If you have time, we can go through this. Let's see. Let's see the next question. Okay, this is about the meaning of the derivative. In section 3.1 and 3.2, actually, we give the definition of the derivative. If you remember our quotient format, maybe I should do the first question for the students who didn't get a chance to watch the video from yesterday. I think I should go through that. Otherwise, it's going to be hard for you guys. Okay, let me do this question, and then we'll move to the next question. Okay, let me copy this down. 2 square root of x, and the point x is 1 over 9, and they're asking about the slope of the tangent, okay, to the curve at the given point, f prime, slope of, okay, this is slope of, which is f prime x 0. Slope of the tangent line to the curve at the given point. They are asking you the derivative actually at x0. x0 is the 1 over 9. The way they state the question is kind of misleading because they are expected to. You guys can see my screen, right? Can you confirm?
Yes.
Okay, very good then. Okay, there are some hands raised. Emirhan, what's the question? Emirhan, please ask the question. Okay, Emirhan probably. Okay, Mohammed Munib, please ask the question. What's your question? I cannot hear you guys. Are you talking? You are muted. You have to open it up first. Let me see if I can unmute you, or you should unmute yourselves to talk. Mohammed
Question 19.
What's that?
Question 19.
Question 19, in which homework, Munib?
Part A.
Excuse me?
Part A, we have to derive an equation for perpendicular to the tangent of the curve.
Okay, which homework can you remind me? Homework 1, 2, 3, which one?
Homework 4.
Homework 4 and question number?
19.
19, okay, I took a note of that. If you can use the chat, you can write the question homework number and the question number there as well, okay? Emirhan, you have a question as well. Please unmute yourself and tell me. Okay, you don't? Okay. All right, so yeah, Ayberk is a question, I think. It's homework 2, question 2. Let me write it down. Homework 2, question 2. I'm taking my notes. Okay, let's start with this and we will get back to the other one. Yeah, Abdullahi, yeah, go ahead and ask me your question. Shukri. Abdi Shukri, can you speak, please? You raise your hand. Okay. If you're not talking, then you can write or you can talk if you want. I'm going to be on the other screen now. Okay, we are going to work on this. All right. So for this, I'm going to go to our screen here. Okay. A new page. This is section 1, page 1. Okay, we are going to be doing homework 4. Problem 1. We are going to do the problem 1 first, okay? All right. Let me make this bigger a bit. All right. So in this question, it says find the slope of the tangent line to the graph. The graph of f of x is equal to f of x is equal to 2 over square root of x. 2, excuse me, square root of x. Okay, that is the question. Okay, and at the point at x is equal to 1 over 9. All right. Okay, I don't know why it's talking by itself. Okay, my cell phone started to talk. All right, so let's give a solution now. Okay, in chapter 3.1, what we see is we gave a definition for the derivative. The definition of the derivative is something you already know, actually. Just a sec, why is it writing that? Okay, I want to do that. Okay, this is the formula. I'm going to use a here. It's equal to the derivative of it's a is going to be the slope. It's the same thing. So the derivative is shown as f prime, and it's the slope. It's slope of the tangent line at a. It has several meanings. So one of the meanings is this, what the derivative is, and I'm going to tell you how we define it. Okay, it is the limit. I'm going to write it in capital. Limit as h goes to 0 or approaches to 0. Okay, approaches to 0. Maybe I should write in letters as well. Limit of the quotient. You remember the quotient, right? It's the quotient that we use. It is f of a plus h a plus h. We use this in rate of change. Okay, we use it everywhere there in the previous in chapter 2. Okay, and then you divide this by h. Okay, if you take the limit of this, you get what you want. All right, so that's what we are going to do in this question too. All right, so I'm gonna write it down. Okay, so the way you're gonna do, all right, so you're gonna write the limit as h. Maybe I should start with the derivative thing. Okay, now from now on, you understand that the derivative at 1/9 is the same as slope. Okay, so limit as h goes to 0. All right, so I'm going to write it down. F 1/9 plus h minus f of 1/9 over h. So I have to find it. Okay, so let me try to get to the right. Okay, yeah, this is what I want to get to. Instead of f, I'm going to write 2/square root of x. Let's open up a new page and continue from there, maybe. Let me see if it's going to allow me to go down a little bit more. Okay. Okay. Oh, come on. Maybe to the right. Yeah, it's going to allow me to go to the right. Okay. Here we continue. We continue with the solution. Solution, all right. Solution. Okay. And I will. Okay. I will just write it down. So I'm going to write m. Here, m is the slope, which is the derivative. Okay. But first, before I do actually this, I would like to deal with the ratio. Okay. I want to do the ratio first. Because if I can calculate, simplify the ratio, I should be okay. I'm going to go open up a little bit more page here. Just a sec. Okay. All right, that's much better. Okay, so here, so what's the ratio? F of x is equal to 2/square root of x, right? So the quotient, the ratio, I mean, it's going to be 2/square root of a plus h, which is 1/9 plus h, okay, minus 2/f of 1/9, which is 1/square root of 1/9, all over, we should say that all over, this is the quotient, it's going to be h, okay, so this is going to be equal to, I'm going to equate the denominators here, but first I want to just okay, first of all, 1/h down here, no problem. And on top, I have this, okay? 2 times 3, because square root of, I'm so sorry. There's a typo here. I'm trying to make it a little bit fast, so it is, okay. Let me rewrite this so that you understand it. 1/9 plus h minus 2/square root of 1/9, right? This is what we have now. Now I am going to, let's move this down here just a sec to open up just room for myself. Okay, good. And then, okay, let's just move it up a little. Okay, so here, so this is equal to 1/h again. I have to do the simplifications now. Okay, I have 2 that's common, so I'm going to factor that out. 2 out, and then I have 1/square root of 1/9 over there, right? What I'm going to do is I'm going to take them up So it's going to be 3 over square root of 1 plus 9h. Okay, do you understand? I'm doing this a little bit faster than, or quicker than you would think. So this is going to be it. Okay? And then what I'm going to do is I am going to equate the denominators. All right? I'm double checking the work. This is 1 over, yeah, I took out the 2 and 3 is common. So I'm going to take out the 3's as well. 6 over h, it is going to be, all right, I'm going to equate the denominators. 1 minus square root of 1 plus 9h, all right, over, okay, square root of 1 plus 9h, okay, on top. All right, so let's continue a little bit more. Maybe to the right if I have room here. I don't think so. Okay. Let me move this a little bit down to create more place here. Okay. All right. So then it's going to be, this is equal to 6 over h. But I have this, if I plug in, I'm going to take the limit. I told you that the slope is the limit of this expression. If I take the limit directly, I have to plug in 0 for h, but it makes the denominator 0. It's not good. So the limit of this is not as good yet. Okay, so I have to work it out a little bit. Like, for example, I can multiply the 1 plus square root of 1 plus 9h, both numerator and the denominator, to get rid of h somehow. I'm trying to get rid of h in the denominator. That's the goal. All right. So if I do that, okay, 1 minus square root of 1 plus 9h, okay, times 1 plus square root of 1 plus 9h. Okay, I'm going to multiply with the same expression down here, square root of 1 plus 9h. Okay, if I plug in h0 in the denominator for this expression, which is, I'm going to circle in red, I don't get any problem. So I want to let it be. I don't want to change anything about that. Okay, it is causing no problems for me for the limit. So I want to keep it there. On the other hand, okay, so 1 plus square root of 1 plus 9h, okay? Okay, so I'm going to close this. Let's go down a little. Okay, and then here, what I'm going to do, I'm going to do the multiplication of the 2 here. 6 over h, and if I multiply the 2, it's the differences of the squares. So it is 1 squared minus, yeah, go ahead.
Is this rationalization we did here?
That is definitely, I mean, you can, rationalizing the numerator, you can say. Okay, we are rationalizing the numerator. We don't rationalize the denominator. Denominator is fine. It doesn't cause us any problems. That's what you're saying is right. Okay, so 1 plus another, if you have any other questions, please ask right now. Okay, when you can ask me, no problem, because I cannot see your hands raised when I'm working on the screen, so you can speak up if you have questions. Is it Munib that was talking? Who was talking?
Yes, ma'am, it was Munib.
Okay, Munib, thanks. Now here we simplified. For example, if I use the red color here, so 1 cancels with this 1 here, I have -9, thank God, because we are going to simplify h's here, right? So I have -9h on top, thank God. We don't care what happens in the rest of it because they are all good expressions. They are not going to cause any problems in the limit. Okay, this is a good expression here, and this is a good expression here. Okay, just we keep it there. All right. Now, what we are going to do, we are going to get rid of the h's here. Okay, so these were causing us problem in the limits. If you let h goes to 0, it's a big problem. So now I'm ready to take the limit, which is going to give me the slope. Okay, So let's go up a little. Okay, so I'm gonna write the formal expression of the derivative. This is f prime. So whenever we see f prime, we should understand that they are talking about the slope in this question, right? It's the limit of this expression. Limit as h goes to 0. It is limit of this. I'm gonna circle it in green. Okay, limit of this quotient is going to give us what we want. So let's copy this down. Negative 54 on top over square root of 1 plus 9h and 1 plus square root of 1 plus 9h. Okay. All right. Let's see. Okay, very well. Well done. Okay, let's use our red color again. If you plug in h goes to 0 here, you're going to get 1 from here. If you plug in h goes to 0 here, you just directly plug in h equals to 0 here, you get 2 from here. Okay, 1 plus 1 is 2. So what is the answer then? It's 54 minus 54 over 2. So we are going to write it down here. Okay, is it negative 27? Yes, it is. Yes. So this is the slope that we have. So we are going to go back to the question 1, and probably we did this, no, we didn't. Okay, they are asking the slope. So I'm going to just write negative 27 and check the answer. Okay, so next question is, okay, it says in a controlled laboratory experiment. Do you guys have any questions, by the way? Just a sec, let me get your questions. Anybody has a question about the solution? Ayberk, go ahead, and Jamil, go ahead if you have questions.
I have a question and I sent it to chat part.
Okay, I have seen it, Ayberk. So we are going to get to it. Jamil, do you have any questions? Thank you, Ayberk.
Professor, could you go back to the question?
Of course, yeah. Let's go back to the original question, you mean?
No, the solution.
The solution, okay.
I'm writing. Could you zoom
up?
Of
course. Yeah. You're writing it down. So how far should I go up?
A little bit.
I can move up. Just tell me, okay?
Okay.
Tell me to stop when you want me to stop.
Yes, sir.
Okay.
And
all right. Okay, yeah. It is this. Okay, should I go down? Are you taking a picture?
Yeah.
Okay, so I'm going down. Maybe like this. Take a picture.
Yes, okay.
And then this is it. Yeah.
Okay, thank you.
Okay, you're welcome. Thank you. Okay, so let's move this up a little. But if they ask you to find the tangent line, let me extend this question and add something on top of this. Instead of just the slope, they may also ask, find the tangent line equation, right? If that's the question, I'm just changing the question a little bit so that you guys know. You would just need to use, let me maybe add this up here. Okay, if I change the question, I add one more part. Let me see if you hear me. Yeah, you hear me. Okay. So I'm going to just write next to here. Okay, so they are, if they say find, okay, tangent line equation is easy as long as you know the slope tangent line equation. It is just what? Y minus y0. In this case, we know x0. This is x0. You can consider this is x0. We know x0, but we don't know y0. But we can take this, put it in the function, and we get that y0 is 6. Okay, so it is 6. it's equal to negative 27 is the slope, and x minus 1 over 9. Okay, this is the tangent line equation. They didn't ask about this, but they might have asked the question. That's how you should proceed, okay? It's just extra information. So let's move to the next page. Okay, I'm back with you. Sorry about the this break, short break. Okay, so let's open up a next page for our records. Okay. Actually, I created a new team where you would be able to, when I do these solutions, you would be able to actually get to the solutions right away. I forgot to use it in the morning, but in the afternoon for my other classes, I will start using it. You would be able to find my writings in there as well. So, but not this one. Okay, maybe I can share this to you too. Okay, let me see. I can share what we do in the morning and previous classes with you after this class, I think, because I'm using your team here, 1011 team. Whenever I have this, whatever I write here, I can share it with you, okay? So that could be useful, but my notes are not really the best when I write them. I write them sideways, up and down. So I hope you can understand. Okay, I'll try to do my best in writing them, okay? Okay, so let's go to the, let me see whether I have any other, yeah, no more questions. Okay, let's go to, let's do the homework 2 question 2 maybe, Iberg's question, and then we will continue homework 4, okay? Homework 2 question 2, let me see, maybe we have solved it before. Okay, so I am going to open up homework 2, problem 2. I think we solved homework 2, problem 2 before. Let me take a look at that. If we had solved it, I'm going to ask you, Ayberk, to go through the yesterday's class videos. Let me see. Yeah, we went over it. Let's see. Okay, Ayberk, do you have any specific questions in here? Like this, you can solve this question similarly, like the one we did in the first question we did. It's the same way. You're going to take the limit in section. Actually, in chapter 2, since we don't know this, we knew that you would take the limit and find it, but we didn't know the name, that it's the derivative. That's the only difference. So I think this is similar, and we have solutions in. I told you I'm going to share this OneNote, and in OneNote we have the solutions somewhere here. Okay, in one of these pages here, you can find the solution. All right. Okay, Ayberk.
Okay, teacher.
Okay, good.
Thank you.
Thank you very much. And it is done. And homework 4. Let's go back to the homework 4. Homework 4. We have 8 minutes, I guess. Homework 4. Let's see. We can go a little bit more and take a late break. We can do that too, because we started late. Yeah, question 2. Okay. They are talking about a controlled laboratory experiment. Yeast cells are grown in an automated cell culture system that counts the number P of cells present at hourly intervals. Okay? So you're counting the number of cells present at hourly intervals. Okay? After 1 hour, P is going to give you a number of yeast or cells that is present. The number after T hours is shown in the accompanying figure. So they gave you the figure. For example, after 1 hour, it is after, let's see, give you a specific one. After 5 hours, it is you have more than 100 yeast cells present. Okay, completes parts A through C below. Okay, that's what they say. Maybe we can make it bigger a little bit. Okay, so what do they say? Explain what is meant by the derivative P prime 4. P prime at 4. What is that? P prime at 4. So it is the derivative, right? It is the slope. It's the rate of change, right? If you look at the P prime 4 in here, P prime 4, you are going to find P prime 4 is actually, we just learned that it's the slope of the tangent line to this curve. Okay, it's going to give you the rate actually for example, in 1 unit, it's going to give you the amount of yeast, the change in the yeast in 1 hour, in 1 unit. Okay, so delta y or delta x, we do that, right? If you remember, as delta x goes to 0. It says choose the correct answer below, and what are its units, they say, and we will read the A, B, C, D. Let's see. The derivative P prime at 4 represents the average number of cells from t is equal to 0 to t is equal to 4. The derivative P prime at 4 represents the average rate of change of the number of cells from t is equal to 0 to t is equal to 4. The derivative P prime at 4 represents the number of cells at t is equal to 4. Okay. And the derivative P prime at 4 represents the rate of change of the number of cells at t is equal to 4. Okay. Which one do you think is the right answer? Is it the average rate or is it the rate of change? Okay. How would you think about that? Okay, I want you to see the help me solve this. The reason is it has some steps that it shows that I don't have to rewrite them, because writing it's kind of time consuming. So I'm going to show you the steps and talk about that together, okay? Okay, so it says, look, it says the following are interpretations for the limit of the difference quotient, which is limit as h goes to 0, f of x0 plus h minus f of x0 over h. Okay, and we know what are the interpretations of this. We just said that it means, first of all, it's the slope of the graph of y is equal to f of x at x is equal to x naught. And another interpretation is slope of the tangent to the curve. Y is equal to f of x at x is equal to x naught. So this derivative thing or the slope thing is going to mean at least 4 things that we have here. Okay. Okay. So this actually this expression, I should say, has at least 4 meanings, 4 different meanings, right? Depending on the situation. Okay, and it's the rate of change of f of x with respect to x at x is equal to x0. That's what it means. And it's the derivative of f prime at x0 at a point. Now, the first two, actually the first interpretation and the second interpretation and the third interpretation, actually we talked about this in just one sec, in chapter 2, okay? Just give me 1 second. Sorry about this. Here, okay, so there are a couple of interpretations. That's what I want to emphasize. The first three of them actually we discussed in chapter 2. This the last one, which we gave a name, formal name of it in chapter 3.1, and it's the derivative. So in that case, the answer is right now is obvious, right? So let's continue to help because choose the correct interpretation of P prime. Now it's gonna represent the rate of change of the number of cells at t is equal to 4. So at t is equal to 4, how many more cells that has been produced? Okay, it's going to give you that. It's going to give you that last 1 hour. What because it goes like in terms of units for each unit. What's the amount of rate of change? That's what it is, right? In some certain interval, you just calculate the change. Okay. Okay. So the answer is going to be B. I need to take a short break. Okay, let's take a break and I will be back in 10 minutes.
şey yetmez.
Okay, I am back with you guys. Yeah, are you here? Okay. Okay. You can say hi. I'm saying hi here.
Hi.
Mm-hmm. Okay, so until which question you are saying, Jamil? I think it should show. Oh, let's see. Yeah, that's a good question. I have to see it. I have to look into it and tell you. Okay, I'm gonna email you on that later. So right now I don't know because I have to go through the. Let me see if I can do that right now. Let me see just a sec. Let me see if I can answer that right now. Okay, let me see. Okay, let me see if I can see that all here. No, it doesn't allow me to see it. Why not? Just a sec. It should. Okay, let's see. I mean, I will be able to see it, but it's gonna take a little bit time. I won't be able to show you right now. Okay, let me work on this, and then I will let you know after I get to it. Okay. So we are gonna open up this homework for again. Okay, we are in question 2. Yeah, we said nice work. Okay. No, let's continue on this. Okay. Okay, so we got that like that. Okay, so we are gonna say, yeah, the units of P are. What is the units of P? First of all, we said T hours, so it's going to be, let's see, cells per hour squared or hours. Which one we have to determine that? Let me see. I'm not sure whether you can see it. I have kind of difficulty seeing all of it. Okay, cells per hour squared. Which one? So time is in terms of hours, so it's not hours squared. And cells, number of cells that are added in 1 hour. So we are going to say cells per hour. We are going to check the answer. Okay, let's see the P. Let's see the P prime, D, delta Y, delta X. Cells per hour. It should be right though. Let's see. Oh, let's read the. Okay, let's read the question again because I probably it's the. Okay, cells present at an okay number after t hours is shown. Delta Y, delta T. It's delta Y, delta T. Why not? It shouldn't be hour per. Let's see. There's a problem in here. Something is not right here. Delta Y. Okay. Let's read this carefully. Just a sec. Choose a interpretation of P prime, and it's the derivative, right? Delta Y, delta X. So it is delta Y is what? Number of cells over delta X. Delta X is the time that has passed because it says number after T hours. And I think this is right. There's a problem in here. Okay. The units of P. P is, of course, see, we didn't read the question carefully. I thought this is the derivative. No, they are talking about the units of P. So it's not cells per hour, it's cells. I'm so sorry about that. It's my bad. Okay, yeah. I thought they're asking about the derivative. The units of time, of course, it is the hours, right? Because it says after T hours. So it is right. One needs to be careful when reading the question, right? Even if you know the answer, if you don't read it right, then you get a wrong answer. Since the difference quotient has only P in the numerator and the units of T in the denominator, the units of P prime at T are, now it's right, it is cells per hour. Okay, check the answer. It is right. Okay, and anything else? Which is larger, P prime 1 or P prime 2? Give reasons for your answer. Okay. what is P prime 1? If you look at the, so P prime 1 and P prime 2, you should look at them as the slopes of the tangent line. Now, what you're going to do is you are going to draw the tangent line to it. And then what I'm going to do, I'm going to use my other screen to show you that, because this is important, okay? Because some students don't know that. Okay, I'm going to show you. I'm going to draw a, okay, let's see. I'm going to draw a similar graph. The graph is looking like this, right? So let's say this is 1. Let's say this is 2, yeah? This is the x-axis. Okay, for some reason I cannot, time t. And then this is the p going up here. P, yeah. And they are asking which one is more, right? Let's get back to it. They are saying which is larger, P prime 1 or P prime 2? Give reasons for your answer. Note that the values P prime 1 and P prime 2 are equal to the slopes of the graph of y is equal to P of t at t is equal to 1 and t is equal to 2 respectively. Okay, so it's giving you the hint. Okay, so if you go back to it, let's draw our tangent line. So I'm going to draw a tangent line at 1 as, with the red color. It is this. Okay, this is the tangent line at t is equal to 1. And then I'm going to use the green color to draw the tangent line at t is equal to 2. Okay, this is the tangent line. Tangent line at time t is equal to 2. Now I have a question. Which one is steeper? Okay, which one is steeper? Which one is steeper? Can you answer? Steep, do you know what steep is?
T equals 2.
T equals to 2 is steeper. So that is going to tell us that the slope corresponding to this, let me call them L1 and L2. The slope of L2 is bigger than, let's write that, L2 is bigger than M represents the slope, L1, okay? Because of that, the answer to this question, okay, the answer to this question, which is larger, P prime 2 is larger, okay? I don't know where to write the answer though. It doesn't give me, okay, so it gives you the hint first, as the slope of the y is equal to P of t at t is equal to 2 is greater than the slope at 1, okay? That's very good. And then let's move on. Therefore, the value of P prime is, what does it say? Yeah, it's greater than, right? Okay. Okay, very good. The quadratic curve capturing the trend of the data points is given by P of t. This, find the instantaneous rate of growth when t is equal to 4 hours. Okay, so they are asking about instantaneous rate of growth. Whenever we talk about the instantaneous rate of growth or instantaneous rate of speed, okay, so we should remember the derivative. Okay, find the instantaneous rate of growth and when t is equal to 4. The instantaneous rate of change of a function, it is giving you the information, we discussed this before, of f at x is equal to x0 is determined by the limit below, provided that the limit exists. Okay, it's the same ratio we are talking over and over again. We just name it differently, okay? So all these names mean the same thing. They refer to the same formulation, okay? All right. So the limit below is equal to the instantaneous rate of growth of P at t is equal to 4 hours. So what you're going to do, you are going to plug it in. Okay, we are given the function P of t Now, instead of at the beginning, they gave us the graph, but then they gave us the formula. Okay, this is the formula that they gave us. Okay, since in the first part they didn't give us the formula, we just said it is greater than blah blah, so we just made estimations. But in here they gave us exactly the formulation, so we can put it in and calculate that. Okay, we just put it in. 4 plus h squared minus 40 times 25, 4 plus h plus 25.75. This is the original function. And then we are going to plug in 4. This is f of 4. This is f of 4 plus h all over h. So then we are going to do the simplification. Let's see. When you expanded it, so you're going to expand this square. Can you see the screen well? Is it clear? I mean, can you read it? Can you see it?
Yes, yes.
Okay, great. And you can expand this squared like this, and the rest is easy. You just do the computation and distributing. And then let's see what is next. And on top, they want you to simplify it. Okay, so you're going to do some simplifications, which I'm going to skip that part. Okay, I'm going to just say, I'm going to just make that up. Okay, 24h. I'm going to just make it up. Okay. And of course, it's not going to be right, okay, because I didn't calculate. I just want to move on. Okay, I want to get to the next one. Yeah, it is giving you the correct answer. When you simplify it, you're going to get a simplified answer like this on top. And you are expected to know how to simplify such expressions for the test, for the quiz 1, all right? And you should show it in your handwritten solutions. So I want to see them. Okay, thank you very much. And let's see. And then what does it say? Since h approaches 0, but h is not 0, cancel h from the numerator and the denominator. That's what we are doing. Okay, we can cancel it out. And then what is left is that just this part. We are going to plug in h, and the answer is 59. Okay, if you cancel the h, then I'm going to rewrite that to 46. It's just taking you through the steps one by one, which is really good for you. Okay, 59. Maybe sometimes it's boring for some students, but it's okay. I mean, it just do it. Okay, because we cancel the h's, and we got an excellent job. Evaluate the limit by substituting h is equal to 0, and the answer is, of course, 59.43. Okay, so let's continue. Therefore, the value of the limit of the difference quotient at t is equal to 4 hours is 59.43. Okay, so let's continue. Thus, the units of the instantaneous rate of growth are, they are talking about the derivative here. Okay, so it's going to be cells per hour again, is it? Right, this is going to be the same thing, cells per hour. Okay, so it's the right answer. And then, so they just rewrite the answer in terms of including the units as well. Okay, that's all to it. Okay, so that's that question. You have some questions probably. Let me check it out here. Anything in the chat? No. Okay. Okay, we are going to get to number 19 in homework 4. Number 19, I think, could be the one of the ones that we didn't cover. This is, which chapter does it say? Which sections?
Hocam pardon.
What's that?
Bu verilen denklemin türevini alıp direkt t yerine 0 yazsak da aynı sonucu bulmuş oluyoruz. Direkt böyle yapsak olur mu?
It's not going to be acceptable yet because we don't know this yet. Okay.
Okay.
It is it is section 3.3 what you're talking about. The shortcuts that you can check your work by doing that, but you should go through the limit definition of the derivative. Okay, Ömer? Okay. So otherwise you're not going to get points. Okay, you have to do it like this because this is just for you to practice the limits. You have to practice the definition of the derivative because this is where it comes from. But afterwards, after section 3.3, you're going to learn the shortcuts, and you don't have to do this over and over. But for the quiz, you have to do it this way. Okay, thank you for the question, actually.
Okay,
it's very
teacher, thank you.
meaningful, very meaningful. Okay, thank you. And this, I got some checks here. I mean, chats here, but this is something else. Yeah. Okay, let's continue, go on. I was trying to open up 19 just to see which section this is from. Okay, yeah, this is section, Munib, this is actually section 3.3, so just bear with us, okay? This is actually, this is where in section 3.3 where you're going to use the shortcuts. See, the questions are the same. Find an equation of the line perpendicular to the tangent to the curve, y is equal to blah blah at the point 4.43, I'm sorry. What's the smallest slope of the curve? At what point does this, on the curve does the curve have this slope? Find equations of the tangents to the curve at the points where the slope of the curve is 32. Now, when you are doing section 3 questions, you can directly take the derivative, and because we will know it by then. So I'm not going to do that for that reason. So let's get back to. Okay, see, it shows which section it is from, so I'm gonna stop when it is at 3.2. Okay, 3.2 is question 11. Everything is included. Okay, so 11 questions from here. All right, so let's move on. Let's get to the question. Okay, question 3, I think we did yesterday with the students here. So I want you to watch the video for that. And question 4 we did as well. Let me double check. Yes, we did this it is in the video as well. Question 5. Question 5, what's the rate of change of the area of a circle with respect to the radius when the radius is r is equal to 3? Okay. So they are talking about the so how are we going to do that? So they are talking about the area of a circle, which is a is equal to pi r squared. But we want to know the rate of change. If you have a circle, let's say you have a balloon, and let's say you are blowing air into the balloon. When you blow air into the balloon, then of course the radius. Let's say our balloon is spherical, like okay, the radius is gonna expand. They want to know what's the rate of change of the area of a circle with respect to the radius. If you change the radius of the circle of this, I mean, in this case, this is circle, but I was talking about the spherical example here. But for the circle, you can just consider a circle, which you can slowly expand at the radius, and then it's talking about rate of change of the area of a circle with respect to the radius. Yeah. Okay, so how would you do? So they are talking about the derivative of the area with respect to the radius r. They are talking about dA, dr. Okay, so let me get to it. All right, so we are going to have another page. Okay, so we are going to consider a circle, and the circle is going to have a radius. Okay, and the area of the circle is pi r squared. Okay, so here we are going to have the rate of change of the area with respect to the time, with respect to the radius, the ADR. So you can consider this, we can write it as A prime as well. But when you write A prime, it's not clear whether you are taking the derivative with respect to R. If you write it in this notation, this is another notation for the derivative, then it's obvious that you're taking it with respect to R. So pi times we take, so for this one, if you knew the shortcut, then we would just say, you would apply the shortcut. Since we talked about the shortcuts, I was going to just take the derivative immediately. But in this case, we still don't know it. We assume that we don't know it. So, and they are talking about the derivative at 3. So what I'm going to do, look, I am going to, this is my circle, this is the derivative, and what they are asking is, they are asking it at r is equal to 3. So I'm going to write the same thing as A prime at 3. So I have to calculate that by using this limit definition. Okay, so I'm going to get to, just a sec. Okay, so I'm going to do that. A prime at 3 is going to be equal to limit as h goes to 0, okay, pi, okay, this is 3 plus h squared minus pi times 3 squared over h. And I'm going to do the simplification, limit as h goes to 0. And pi's are the same. I can take the pi's out. Okay, pi's are the same. I factored it out. And I have differences of 2 squares, and 3 plus h minus 3 and 3 plus h plus 3 over h. Okay, so here, so 3's are going to cancel, and I have h's are going to cancel as well. Here h, they are going to go away too. Okay, it's going to be 1 here, 1. Okay, so what is left is, we just plug in h is equal to 0. The answer is 9. Okay, so this is the rate of change of the area with respect to the radius. Okay. Sorry, pi is missing, right? We have to put the pi in. If we don't put the pi in, then it's wrong. Okay, so we have to, because here we have a pi. Okay, let's get to it. And this is 9 times pi, 9 pi. Let's check the answer. What was wrong?
Hocam 6 pi olacak çünkü.
I guess. Okay, where did I go? Is it 6p? Okay, sorry about that. Okay, let's see. Yeah, how come I got 9? Okay, sorry about that. Let me write that. For some reason, I got 9 in there. Okay, that's the answer. Okay, so let's continue here. Okay, this is a question 6. Does knowing that a function f of x is differentiable at x is equal to 0 tell you anything about the differentiability of the function negative f at x is equal to x0? Give reasons for your answer. So this is about the differentiability. And I talked about the differentiability. It is section 3.2, okay? And in my talk, in my lecture, I said that differentiability is stronger than continuity. So if a function is differentiable, then that function is continuous. And okay, and this question is actually saying, let's say you know that f is differentiable at x is equal to 0, x0. So let me remind you what differentiability is. Okay, let me remind you, because for students who has not seen the recording yet, I have to talk to you a little bit about that. Okay, let's do that. Okay, we are going to say a function f is differentiable at a point, differentiable at x is equal to x0 if, okay, if this limit exists and it's finite. I mean, if this limit is finite as h goes to 0, f of x0 plus h minus f of x0 over h. And actually, in my talk, I introduced another definition, which is f prime x0 is limit, okay, limit as z approaches to x0, z approaches to x0, f of z minus f of x0, okay, z minus x0. So this is another version of this. They are equivalent. They are equivalent. So if these limits are, let me see just a sec. If these limits are finite, okay, then the function is said to be differentiable. Okay, has to be finite. Okay, exists. This limit exists. Limit exists. Has to exist. It has to exist. If it doesn't exist, you cannot talk about that. Similarly here, limit has to exist to have a differentiable, to have the differentiability. Okay. Now, in this question, it is saying, let's get back to the question. So let's say you know this much, and it says, let's say you know f is differentiable at x0. Can we say anything about the negative f being differentiable at the same point? What do you think? Do you agree or not? Or we can read the question. Function f is if a function f is differentiable at x is equal to x0, then negative f is not necessarily differentiable at x is equal to x0 because limit of negative f of x is not known. This is not true because there's no relationship between the differentiability and this limit. Let's read the B. If a function f is differentiable at x is equal to x0, then negative f is not necessarily differentiable at x is equal to x0 because the slope of negative f of x is not known. First of all, there's a relationship between the slope of the f and slope of the negative f. So this is not true either. If a function f is differentiable at x is equal to x0, then negative f is also differentiable at x is equal to x0 because if it has a slope at x is equal to x0, it will have the negative of that slope when it's reflected across the x-axis. What do you think? And let's read the last one. If a function f is differentiable at x is equal to x0, then negative f is not necessarily differentiable at x is equal to x0 because negative f is undefined. Okay? What do you think the answer could be?
C.
That's true. The answer is C because everything depends on the formulation that we just said. Let's go back to our formulation. We just look at this limit. If this is negative f or f, it doesn't really matter because if it is negative f, this limit is going to still exist, right? It's just a negative of that slope that you're going to get because of that. Because of that, the answer is C. Okay. Okay. It says differentiate the function and find the slope of the tangent line at the given value of the independent variable. So this is very similar to what we had done before. You're going to apply this formulation. That's all you would need. So I'm going to just skip that if I can. I'm going to skip. And it says differentiate the function. What does it mean? You're going to use that limit definition again, okay, in order to differentiate it. Then find an equation of the tangent line at the indicated point on the graph of the function. Okay, so this is the similar thing too. If you want me to do, I'm going to do it, but let's go through all of them first before the class is over. Graph the derivative of the function graphed on the right. Now we have such a, this is a good thing. I mentioned this in my lecture too. Okay. So here, this is the graph of f. Okay. And what they want you to do is they want you to draw the graph of f prime. Okay. So this is kind of challenging, but what you need to do, there are a couple of parts that you have to be careful about. And if you pay attention to these details, then you don't have to worry yourselves. The answer is going to be just coming in front of you. Okay, so first of all, what does it mean derivative? Derivative means it is the slope. If a function is, let me do some drawing here. Maybe it's much better for you guys. Okay, so let me do some talks here. So let's see. Okay, I'm going to talk to you about the parabola first. Y is equal to x squared. Okay, I want you to look at the slopes, or tangent lines at these points. Look at that. Okay, I have this tangent line and I have this tangent line. Okay, so do you see that this tangent line, or can you say anything about this tangent line? If a line is going down, the slope is negative, m is negative. You know that, right? If a line is going up, the slope is positive. Do you guys remember that from high school? Okay, yeah. So this is going to tell us that here, on this part, m is definitely negative. And here, m is definitely greater than 0. But what is m? M is the derivative of the function at that point. Let's say this point is 2, f prime at negative 2, I'm sorry. And let's say this point is, let me use a different color here. Okay, let's say this is the point negative 2, and then this is the point 2. All right. And here, slope means it's the derivative at 2. Okay, so if you want to, let's try to draw the graph of f prime here first, okay? So the derivative, the graph for, this is f, let's say this is f. How would you draw the graph of f prime here? Here, until 0, this is 0, right? This is the y-axis. Let me draw the y-axis too. Let's do it on this simple question, and then let me write an example here. I made up an example here. And the question is draw the graph of f prime. Okay, now the graph that I'm gonna draw, it doesn't have to be really exact. Okay, what I'm gonna draw is what I know in my graph is, let me draw my x and y axis. I know until 0 the derivative is negative, so I can just draw a negative line here until here, and then after 0 I know the slope is positive. Okay, I just want to draw, or I can do a curved one. I don't care. Okay, maybe I should do a curved one that's under. Okay, let's erase that because I don't want to confuse you on that. Okay, let's erase this too, because the questions that they are asking, they don't want you to draw the exact graph. They want you to just find, choose one of among the ones. Okay, so I know before 0 the derivative is negative, so I'm until here. It's at 0, it is the derivative is 0 because we have horizontal tangent line here, horizontal tangent line, horizontal tangent line. Okay, so it is 0, and then afterwards it's going to be a positive slope. So I can draw such a picture for the derivative. So this is the graph of the derivative. Okay, it's the graph of derivative, but it's a rough picture of it. It's a rough picture of it. Okay. So let's get back to the question we have. This is a rough graph. Rough means it's not exact. Okay, rough graph. We don't want to be very exact when we draw, because you still don't know how to draw graphs. In the future, I'm gonna teach you how to draw graphs exactly. Okay, you're not ready for it yet. Okay, so let's look at this one, and I want you to look at this function, and you would see that this function is going down. It's decreasing. okay? And if you go back to the previous question, see, whenever the function is decreasing, the slope is negative. Whenever the function is increasing, the slope is positive. So there's a relationship between the slope and being decreasing, increasing. So if you get back to the previous question, see, the graph is decreasing, going down, down, down. Yeah. So that is going to tell us that if you draw tangent lines to it, let me draw that for you guys. Okay, I'm going to draw that here. Exactly, the exact. Okay, so it is this one, and it's going down like this, right? It's going down like this. Even if it may not go through the origin, doesn't matter. Okay, I'm going to draw the tangent lines here. Look, draw a tangent line at this point. Draw a tangent line at this point. Draw another tangent line at this point. And draw another tangent line. The slope is always negative, right? Negative. Okay, so I expect, okay, we don't know what happens at 0. Maybe the slope is 0, maybe, okay? Maybe the slope is 0 or not, we don't know. It may be, okay? But when you go back to the question, we know that the slope is always negative. So let's look at the answers here. Which one has all the values negative other than the 0 at 0? So A has such a thing. Look, the derivative is all negative here. Here it takes positive values as well. This can't happen. And here the derivative has positive values. It can happen. And here it has positive values. It cannot happen. So we are going to say A is the answer for this question. That's how you should get to it. You don't have to draw exact graph of it. Okay, so I think we have 10 minutes left. Compute the right hand and left hand derivatives as limits and check whether the function is differentiable at the point P or not. Now, let me introduce you right hand derivative and left hand derivative, okay? So let's talk about this a little bit, because I talked about this in the lecture, okay? So right hand derivative is just one-sided limit of the expression. Look, this is limit, this is equal to h approaches to 0 from the right, okay, f of a plus h minus f of a over h. So we are using the same formula over and over, but we are approaching h from the right, okay? And then you can guess the left hand derivative, which is left hand derivative. This is limit as h approaches to 0 from the left, f a plus h minus f of a over h. Okay, so this is left hand and right hand derivative. And why do we need them? Actually, if you remember, for continuity, we have the right limit, left limit. If the right limit, left limit exists, then the limit exists. And for the continuity, we require it for sure, blah, blah. Now, for the derivative differentiation, for differentiability, we would require that f is differentiable at a. F is differentiable at a if a right hand derivative is equal to left hand derivative. Okay, but you might still have one-sided derivative as well, because sometimes functions are defined on an interval, on a closed interval, and the function is not defined outside of this interval. Then you can talk about the continuity one-sided. You can talk about the one-sided derivatives as well. Okay. Okay, let's get back to this question. Okay, compute the right hand and left hand derivatives as limits and check whether the function is differentiable at the point P. In my lecture, actually, I gave an example for the absolute value of x. We calculated the right hand derivative and left hand derivative, and we saw that they don't agree. So the absolute value function is not differentiable at 0. I showed it in the lecture. It's a very important actual example you should keep in mind. It's very important. And here they have a different question, which is y is equal to x squared minus 4. I want to make this a little bit bigger. For differentiability, there are some points that looks like a corner. Like here at this point, it looks like a corner. Whenever we have corners, we do not expect differentiability, like the corner at the absolute value of x. Okay, so we see that this is not going to happen, but let's check it out. We are going to calculate the right-hand limit and right-hand derivative, and see and left-hand derivative, and see whether they agree or not. So how would you do that? F on the right, it's this. So there are two pieces. This is a piecewise function. On the left, it's a part of the parabola. On the right, it's a line. So if you're approaching h from the right, then you have to use this line equation and find the derivative. So if you do that, you are going to get the derivative. If you calculate the long computation, you're going to get it as 2. Okay? Okay, let's check the answer. You have to do this limit, taking the limit, putting it inside. Instead of f, you just put 2 times 0 plus h. Okay, let me do that maybe. Let me do that. 2x minus 4, right? I just wanted to save a little bit time. Okay, we can move to the right. Okay, let's do that. Right hand derivative, okay, it is limit as h goes to 0 to it's 0, right? So it's going to be 2x minus 4. It is 0 plus h minus 4 minus at 0, it is a negative 4. Okay, all over h, all over h. So this is going to cancel with this one, and I have 2h on top. 2h over h, I'm gonna get 2 from this one. Okay, so the right hand derivative is 2, as you had seen in the expression. Let's look at the left hand derivative. The left hand derivative, if you do it in this long way, which you are expected to do, and then you are going to see that it is 0. It is 0. Okay, let's check that. Let's check that answer. Okay, you have to do this long way. Is the given function differentiable at the point P? We look at the right hand derivative, we look at the left hand derivative, they do not agree. So we are going to say no, they are not. I mean, this function is not differentiable at the point P. It could be differentiable at another point, but not at 0 at this point P. Any questions so far? Do you have any questions? Okay.
How could it be differentiable?
So how are we going to show that something is differentiable at a point? Is that the question, Jamil?
Yeah.
Okay. So let's say, again, we are going to use the same thing. So let's say let's give you an answer. Okay. Let's show that x squared is, y is equal to x squared is differentiable at 0. Okay, let's do that. So you're going to use this formulation, and you're going to find right hand derivative, left hand derivative, and if they agree, then you're good. Okay, so do you want me to solve a problem, or is this clear?
You mean if both of them are, for example, equals to 2?
Right.
So they're okay.
If both of them equals 2, then the limit as h goes to 0 itself is going to exist. So this limit, because this limit actually depends on the right limit and left limit, right? If the right limit and left limit exist, then the limit exists itself, right? So then the derivative exists, because derivative is the limit of that expression. So we are going to say f is differentiable because of that.
Okay, got it. Thank you.
Okay, you just check the right hand derivative and left hand derivative. If they agree, you are good to go. You can say this function is differentiable at that point.
Okay.
Okay, that's a very good question. The figure below shows the graph of a function over the closed interval -4 to 4, complete parts A through C to the right. At what domain? This is the butterfly example, but this butterfly function is just the other way around, right? It's not, it looks like a butterfly function. At what point, at what domain points does the function appear to be differentiable? So first of all, the critical points, the points that are going to cause us problems are the origin and -4 and 4, okay? So the origin is a problem because there are some conditions. We said that if a function is differentiable, it is continuous automatically, but if a function is continuous, it doesn't imply always that it is differentiable. For example, absolute value of x is a continuous function, but it's not differentiable at 0. And here, not continuous at all. So if a function is not continuous at a point, then it's not differentiable at that point. So at 0, the function is not continuous. So I want to show you the steps and talk over that. Okay, so it says, let's see them. Any hints they offer? No, it's fine. I just wanted to see if they make it much clear for you. Okay, no. Anyways, so yeah, so at 0 there's a problem. Okay, at the endpoints we may have, for example, at 3 we may have right-hand derivative, and at 2 from the left we might have left-hand derivative. It seems I think we do, because we don't see any extraordinary. It's just a curve coming towards. So we are gonna say, at what domain points does the function appear to be differentiable? We are going to say -3 to -3 included until 0, and then 0 to 2, 0 excluded. Of course, we have to say as the answer A. Okay. So let's move to the next one. At what domain points does the function appear to be continuous but not differentiable? Actually, it's the same. Like, it is continuous over here. Okay, -3 to 0, and it's continuous 0 to 2. However, this is none actually. It's none because it says we want it to be not differentiable. It's not differentiable. It's 0, but it's, so the answer is none, obviously. Okay. At what points, domain points, does the function appear to be neither continuous nor differentiable? At what points? Neither continuous nor differentiable. It is the 0 that we have. We just talked about that. Okay. All right. Okay. I think time. Yeah. And this is 3.3, by the way. Okay, we are good. So we finished it all. So expect questions similar to these questions in the quiz 1. That's it. Yeah, that's all I can do for today's class. Any questions? Do you have any questions? No questions? Okay.
Teacher, I have a
No.
question.
I said bye. Can we leave, teacher, now?
Please do that. Yeah. Thank you very much.
I wrote bye. See you, teacher. Bye.
Have a nice day, doctor.
Bye-bye. Take care.
Teacher,
What's that?
me, Ayberk.
You have a question? I didn't understand.
I want to ask a question
Sure.
about quiz.
Go ahead.
Will
Yes,
we
please do
use
that.
calculators?
Instead of calculators, you can use Wolfram Alpha. I want you to get used to the Wolfram Alpha. Not everybody has calculators. I want you to use the Wolfram Alpha. Don't use calculators. Get used to Wolfram Alpha.
Okay.
You are not going to need a lot of computations. Okay, you are going to need to see if maybe check your graphs, etc. So yeah, use the Wolfram Alpha, please.
Okay. Thank you. See you.
Thank you very much. That's a good question.
See you.
Any other questions? See you. Bye-bye. Take care.
Thank you for your offers, Professor. See you.
Thank you, Jamil. Thank you.